Hello everyone. In this section we're going to talk about maximum and minimums, and you probably remember from previous courses you discussed relative maxes and relative mins. Basically, the difference between absolutes and relatives, also known as locals, is that the absolute is the biggest or the smallest, while the relative is it is a max or a min, but it's not the biggest or the smallest. Now, the location and existence of these lovely things depends on both the function that you're working with and whatever interval that you're talking about. Now, none is also an option. In this graph that we're looking at, we have no absolute minimum, because they continue off into negative infinity. You can also have no absolute maximum if it continued into positive infinity. So both of those are possible. For the moment, let us work on a smaller scale. So we want to sketch a possible graph of a function that has an absolute max, a local min, but has no absolute minimum on the interval 0, 3. So for this, the 0, 3 is the x's that we're talking about, so 2 and 4. And then that would be -1. And the y's can be as big or as small as you want. I'm not even going to put a y possibility because I'm not really worried about that for the moment. What I am worried about is what they're asking me for. So an absolute maximum means that that maximum can't be any higher. But I also will have a local minimum, but no absolute minimum. So I'm going to go into negative infinity for this negative infinity for this no absolute minimum. So if -3 here, +3, my bad, has no absolute minimum, then it's probably easiest to just go whee, and hey, look, that continues down to negative infinity, so this means that there's no absolute minimum. Okay, and I'll just treat that x equals 3 as an asymptote, a line that is approached but never touched. So for an absolute max, I'll need a maximum somewhere. We'll just put it here. Let's put it there. But I also need a local minimum. So if that's the no absolute minimum, then I'll need just a wee bit of a wiggle to give me a local minimum, and then an absolute max. And it can't go anywhere because that would give me no absolute maximum. So I'll just go back down and I'll end it right there. I could keep going that way just like a sine wave, but since I'm only interested in the interval from 0 to 3, this is enough. Now, this is a possible sketch using the definitions that we know. This is not, and by no means, the only version that this could possibly take. So use what you know and just guess at a reasonably good approximation. That's enough. Okay, so for our next example, reiterating the difference between locals and relatives, they're the same, two words mean the same thing, and the absolutes. So we have this lovely graph here, and we want to identify the points from interval A to B in which local and absolute extreme values occur. So when they're talking about extreme values, they're talking maxes and mins. Okay, so we're going to want to know about the local max, the absolute max, the local min, and the absolute min. Okay, and all of these will be x equals. So we don't know what the y is, but we can figure out the x because of what they give us. So local maxes. Well, there's a max here, and a max there. So that would be at P, at R, and at B itself. Okay. The absolute max would be the one that is the largest. So that looks like P to me. The local min would be here, here, and here. So that would be at x equals A, x equals Q, and x equals S. The smallest would be at x equals A. Now be careful here. Look at the interval that they gave us. It is bracketed, which means it is inclusive. If it was exclusive, it would be in parentheses, and we would not be able to include the A or the B in our function part. So do be careful there. Good news for us is that usually they're talking about inclusive anyway, but just in case. Okay, so why do we care about max and mins? Well, that's one thing to look about it, but the other part is for the critical values. So critical values occur at a max or a min. They're also known as extreme values, but we talked about those. The absolute max and min are the critical values. So there's slight difference there, but not by much. Critical values are critical points. Now, because of how derivatives work, meaning that the derivative is the slope of the function, and a max or a min occurs at the top of the peak or the bottom of the valley, that means that if you have a max or a min, whether it's local or whether it's absolute, then the derivative's slope will be 0 at that x value every time. So that is where we get these two theorems, the local and the absolute. So there are a couple of cases where that doesn't quite work, and I have included them in these 4 little examples of where the local min exists but the derivative doesn't. So it doesn't quite work, but that is why you have these theorems. In general, 90% of the time, the theorem works just fine. It's just every now and then you'll get one of these. So do be careful, but these are the just-in-cases, not the usuals. Okay, so usually, when they ask us to find the critical point, this is quite simple. What we're going to do is we are going to, tablet's helping me, we're going to find the derivative, particularly the first derivative. Oops. Okay, we will set that equal to 0 and solve. So, we have our lovely function here, and now that we have spent several chapters figuring out how to find derivatives, we can actually do so. So, f prime, first derivative, of this lovely thing, using the power rule, the power comes out front, and then we go down a power, so 4 times 2 is 8x, and then minus 3. So we're going to set that equal to 0, and we're going to solve for x. So that means 8x equals 3, and x equals 3/8. So at the point x equals 3/8, we have a critical value. And the critical value means that we would have either a max or a min there. We don't quite know which one yet, but we'll get there. Okay. So, determine the location and value of the absolute extremes, max or min, of this function on the given interval, if they exist. Well, make sure that you stay within that interval. If we get outside the interval, then we're going to have a problem because it won't work right. Or you'll get an answer, but it won't match theirs because they're following the interval and you aren't. So be careful of the interval just on that one particular case, but otherwise it works the same way. So we're going to find the critical values. So find the derivative. So f prime. Now why am I using f prime here instead of dy dx? Well, they gave me f of x. So f prime as the derivative instead of dy dx is just natural. But it is the same thing, right? So times 3, so that would be 4x squared plus 14x minus 8. So that would be our derivative, and we're going to set this equal to 0, and we're going to solve for x. Now you can use whatever way you wish in which to do this, from your factoring to the quadratic formula. Whichever way, I'm easy. You just have to finish it. So the first thing I notice is that 4, 14, and 8 are all even numbers. So I can pull out a 2 there. And that does not look nice. So let me do the... yeah, that doesn't look nice at all. Let's do the quadratic formula. So negative b plus or minus the square root b squared minus 4ac all over 2a. So that's negative 7 plus or minus the square root 7 squared minus 4 times 2 times negative 4 all over 2 times 2. So work this with our lovely master magic wand of a calculator. Let's see here. So that's square root of 81 over 4, which is 9. So those are all whole numbers, so I can pull them apart into the positive and the negative. Okay, so that is 5/4 and negative 13/4. What happened? That's not right. Oh, oops. Call me looking, and I missed. This is very common. Be careful. That's a 7, and it magically changed to a 4 because I was trying to talk and write at the same time. So, 1/2, negative 16/4, so that's negative 4. Okay, much better. Now, because of the interval on which they gave me, I'm going from negative 5 to 1, and those are x values, so both of these numbers will be a critical value, either a max or a min. So how do I tell whether it's a max or a min? Well, how about plugging it into the original function? So, if I plug in 1/2 into the original, not the derivative, but the original, then do it in your calculator, I get negative 25 over 12. Okay, so do the same thing but for the other one. So f of negative 4, put that into my lovely original function. and I get 176/3. So at f of 1/2, this is a negative, so this will be a absolute min, and this is a positive, so this would be an absolute max. Now this doesn't mean that all positives will be absolute maxes, but since a positive number is definitely bigger than the negative number from the 1/2 versus the -4th, it's much easier to tell. Okay, so let's do it again. Determine the location and value of the absolute extremes. So same directions on this given interval. So once again, find the derivative. So f prime, this would be the chain rule. So the power rule, 4/3 u to the 1/3 times u prime, where u is x minus 3. Oops. Times, well, the derivative of x minus 3 is 1, right? So that doesn't change much. Okay. So if we set that equal to 0 and solve for x, zero divided by anything is 0. How do you get rid of a cube root? 1/3 power is a cube root, remember? Well, we would cube it. So that'd be x minus 3 equals, well, 0 cubed is still 0. So x equals 3. Okay. Now, if we plug this into the original function, we're going to get 0 because of how that function is. I mean, 3 minus 3 is 0 to the 4/3 power. Well, 0 to any power is still going to give you 0. So this is probably an absolute minimum. But it's a little hard to tell because I don't have anything to compare it to. So let's check the ends, shall we? The intervals. So f of -8 and f of 8. I want to check both. So put it in your calculator. -8 minus 3 to the 4/3 power will give me 24.46-ish. And same thing to a positive 8, pardon me. That gives me 8.5, 55. Okay, so this means that my absolute minimum will be the 0. But for my absolute max, it would be the -8 here. I have nothing else to compare it to for the critical value. And to be clear, these two endpoints are not critical values if you view it as a whole of the entire function. But since they relegated us to a very specific interval, this is the way we have to do it. It's not a perfect, and if we looked at it as a whole, it's not an absolute. It's probably not even a relative. But because we are working on this specific interval, we have to look at the endpoints as well to determine the maxes and mins at those points.